Hello, and welcome to this edition of Wolfram Experts Live. My name is Philipp Blume. I'm your host, and I'm glad you could join us. For 26 years and a day, Wolfram has been dedicated to maximizing the accessibility and comprehensiveness of computational knowledge. The new product that we're going to talk about today represents a big leap forward in both respects: the Wolfram Programming Cloud. The Programming Cloud allows anyone with a browser to take advantage of Wolfram's technology and to instantly deploy their own content and applications. The purpose of this virtual event, then, is to introduce you to the Programming Cloud and to provide a few tutorials. So let's begin by introducing our panel members. Our first presenter is here on my left. It's Christopher Carlson. He's a senior user interface developer with the company, and his pre-recorded presentation will cover how to program in the cloud, and you'll be able to follow along even if you have little or no experience with the Wolfram language itself. Our second presentation is by Andrew Laix, a lead architect for Wolfram products. He will be discussing deployment and web page creation in the cloud, among other exciting capabilities. Next, we'll have senior kernel developer Joel Klein, whose talk will cover the concept of cloud objects and how these are managed. Near the end of our program today, we'll invite one more panel member to the table. That's lead business analyst Clayton Voyles, who will talk about the business end of things, including pricing and subscription options. We'll have limited time for questions after each presentation, and we'll save a few minutes for an open Q&A at the end. Should you have any question at any time, please type it into the Q&A pod that appears on your screen, and also the chat lounge will be open following the presentations. I hope you're as excited about this event as I am, so without further delay, here's Chris Carlson's pre-recorded presentation about programming in the cloud.
Hi, I'm Chris Carlson, and I'm here to show you how to get started with Wolfram Programming Cloud, an online development environment accessible from your browser where you can write and deploy programs in the Wolfram language. I'll show you how to get online, how to use the Programming Cloud interface, and how to write and deploy programs in the cloud. To get started, go to www.wolframcloud.com and click Wolfram Programming Cloud. You'll see the sign-in screen. If you don't already have an account, click Create Account to get one. Anyone can get a free Wolfram Cloud account with a basic level of access to the Programming Cloud. Sign into the cloud with your account name and password, and you should arrive at the home screen of the Wolfram Programming Cloud. The items on the left are resources and shortcuts to help you get to work, and the ones on the right are something similar to a file browser where you can manage your cloud objects. To get started writing code, click Create a New Notebook. You can give the notebook a name by clicking here and typing the name. Notebook documents are where you write code in Wolfram Programming Cloud. They're useful for a number of other things as well, like making presentations and testing code, but I'll focus on programming here. If you're familiar with Mathematica, you'll feel completely at home on cloud notebooks. If you aren't yet familiar with the Wolfram language, stick around. I'll show you how it works. You can use the Wolfram language in the cloud like a calculator, type an expression like 100 factorial, and evaluate it by typing Shift Return. You immediately get an answer. The input and output reside in cells, which are indicated by the brackets at the right. Hover over a bracket, and you'll see a gear icon that you can click for a menu of operations useful for managing cells. There are lots of kinds of cells which you can mix freely with inputs and outputs to document your work and give structure to your calculations. Add a text cell to a document by clicking the input tongue and selecting plain text. Add title and section tells to structure your notebook. The Cloud interface has a lot of helpful features that help you find your way around the Wolfram language, like this toolbar that appears after you do an evaluation. It's called the Suggestions bar, and it contains operations you might want to do next on the output you just got. It helps you get work done quickly and learn the Wolfram language. If you click, for example, prime factorization, it will not only give you the prime factors of this huge number, but also show you what you could have typed to get the same result in the Wolfram language. Now you know that factor integer is the function that gives you the prime factors of a number, and that you apply the function using square brackets. So you can type factor integer 100 and shift return to get the prime factors of 100, namely 2 2s and 2 5s. If you don't want to see the suggestions bar, click the X at the right to minimize it. You can always get it back again by clicking the arrow. For those of you who are completely new to the Wolfram language, you don't have to know the specifics of Wolfram language syntax to get something done. You can program using natural language. For example, to enter today's date, type Control equal and today. When you evaluate that expression, it will turn into what you could have typed with exact Wolfram language syntax to specify today's date. You can use natural language input right in the middle of calculations. Say you want to know the number of days since the beginning of the year. Type Control equal today, right arrow, minus Control equal January 1st, and then Shift Enter to evaluate. You can click the Wolfram language expressions to extract them. There are several code assist features in the Cloud interface that help you use Wolfram language functions. When you start typing a function name, a completion menu pops up with likely names that you intend to type. Type return to complete the function name with the item selected in the menu, or click the name you want. Click the down arrows that pop up next to a function name to select an argument template. And then type the arguments using Tab to advance to the next placeholder. You can get complete documentation for a function by hovering over the function name and clicking the I. The documentation appears in a pane to the right of the notebook. You can work with the notebook and the documentation pane side by side for quick access to function descriptions. The easiest way to learn the Wolfram language is to copy and paste examples from the documentation to try things out. You can explore by editing the example inputs and re-evaluating. A faster way to do the same kind of exploration is to use manipulate to make an example interactive. Wrap the expression with manipulate, replace the value you want to explore with a variable, t in this case, and specify the range of the variable. Now you have an interactive widget that you can use to quickly explore variations in the example code. You can get a lot of work done just by evaluating these kinds of simple one-line expressions of built-in functions. But the real power of the Wolfram language comes into play when you define your own functions. Here's how to make a function that returns how many days ago a particular date was. I'll call the function days ago and give it an argument of date. And I'll define that to mean today minus date. Evaluate that definition with shift return, and now you can use the function by invoking it with a particular date. For example, days ago, January 1st. Now let's make that function available to the world by deploying it to the cloud. Type cloud deploy form function, specify that the argument date is a date, and make the deployment call the function days ago with the date argument. When you evaluate cloud deploy, you get a cloud object. Click the link in the cloud object, and you get a form where you can enter a date and get the result. The form contains smart fields. You can enter a date in any common format. If you enter something that's not a date, it'll complain. You can make a function that evaluates directly without the intervention of a form by using API function instead of form function. You call this function by specifying the date as a query string in the URL. You can also call this cloud function programmatically from the Wolfram language using URL execute. And you can do it anywhere, in the cloud or from the desktop. I'm going to switch to Wolfram Desktop and call this cloud function from there. Type URL execute, give it the cloud object, and specify the date. So now you have a function that lives in the cloud but can be used in Wolfram language programs just like any other function. In fact, you can call this cloud function from just about any programming environment. To call the function from Python, for example, evaluate embed code cloud object Python. You'll get the Python code that you can drop into your project to call the function. You can also put computed content on web pages using Cloud Deploy. Here's a web API that gives the current temperature. Visit the link and you'll see the current temperature. Right now, this is a private API accessible only to me, but you can make it accessible to the world by adding public permissions. To embed this on a web page, you apply embed code to the cloud object. Copy the HTML expression in the output and paste it into the HTML source for your web page. When you open the web page in a browser, it shows the current temperature at the location of the visitor. The embed code gives a default size for the iframe and frame style. You can edit that to improve the appearance of the page. So now you know how to get online, how to write a simple Wolfram language program, and how to deploy it in the cloud. The notebooks and cloud objects I've been working with are listed in the Cloud Files browser on the right. Under Home, you'll see the notebook we've been working on. And under Deployments, Instant Web Forms, you'll see the web form that I deployed. If you hover over an item, you'll see the gear that pops up a menu of items like Delete for managing objects. You can track your cloud usage in the usage dashboard accessible from the Wolfram Programming Cloud homepage. It shows you how you've used your cloud credits and how many you have left. You can learn more about the Wolfram language and what you can do in the Wolfram Programming Cloud by visiting the Wolfram language examples that are linked from the Wolfram Programming Cloud homepage. Each example contains Wolfram language code and an explanation of how it works. You can try out the code yourself in your cloud account by clicking the Open Live Version button at the top. For help with Wolfram language questions, try visiting the Wolfram community page, which is also linked from the Wolfram Programming Cloud homepage. Community is a group of over 4,500 people and growing who discuss Wolfram language and other Wolfram technology issues. Members can often answer questions, and you'll also find lots of interesting applications of the Wolfram language here. If you try out the Wolfram Programming Cloud, let us know how you like it by sending a message with the feedback button. I hope you enjoy exploring. You can do incredible things with the Wolfram language, and now that it's in the cloud, it's easier than it ever has been to use. Let us know what great things you do.
Okay, thank you for that. Now we're going to have a short period for questions for Christopher. You want to go ahead and take these?
Sure. Somebody asked if the cloud is available right now. It is, and you can get online in the cloud as the presentation's running. What's the difference between the Wolfram Desktop and Mathematica 10? So as far as the Wolfram language goes, the language features that are in the desktop, between desktop and Mathematica 10, not the cloud and Mathematica 10. Both are local clients, local programs that run on your laptop, on your computer. And Mathematica 10 is like Mathematica has always been. Wolfram Desktop is essentially has all the features of Mathematica 10, but is coupled more tightly to the cloud. And for example, when you open notebooks, you have access to the cloud notebooks. I don't believe you have access to local notebooks. Is there something analogous to palettes in the online version? No, there's not. Palettes that live in their own window are not supported in the cloud. You can use the button functionality that lives in palettes from within a notebook in the cloud. I'm pretty certain without having tried it that will work, but you can't put that in a separate window. Can the widget be embedded into something like HTML? So I believe that question is asking about the last example that I gave in the presentation, which is you can export essentially a widget as a cloud object, and then you can use embed code to get the HTML that will embed that widget into any HTML page in an iframe. So yes, and anything you can deploy, you can embed within any HTML page. Which languages are supported for embedding code? Right now, let me go to the cloud and look at embed code environments, and this will give me the list. So this is what's currently supported. C#, C++, Visual Studio, HTML, Java, and so on, down to Visual Basic. This is an expanding list, so I'm told that there is support, for example, for Objective-C coming, and I imagine it will continue to grow in the future. We aspire to support as much as we can any reasonable programming environment. Can you upload Mathematica 10 package files that can be referenced by the web-based Wolfram notebook? Yes, you can. It's something that I haven't tried myself, so I can't get the specifics of how it works, but I believe it just works. Is that right, Andrew?
Yeah, I haven't tried it, but your cloud file system works like your local file system. You should be able to put and get. So if you upload a file to your home directory or subdirectory, you should just be able to get it and use it.
And presumably the standard packages, which are available from Mathematica, are also available in the cloud implementation. So, right. I mean, the environments should essentially be the same on the desktop or in the cloud, with some exceptions like, for example, current image, which accesses your camera, will not work in the cloud. But for the most part, anything that will work in the desktop will work in the cloud, and vice versa. And we've set it up so that you can very easily migrate your notebooks from the desktop into the cloud, back into the desktop. You can work very fluidly between them. So we want to support that compatibility.
Okay, so I think we need to move on to the next presentation, and we'll have more time later for more questions for Chris as it becomes possible. So Andrew will now be talking about cloud deployment. Go ahead, Andrew.
All right, thank you, Philip. Yeah, I'm going to be speaking about the various ways we can deploy things in the cloud. I'll probably be expanding on a few of the examples that Chris showed in his video. So let me start by discussing just the most basic kind of deployment, which is a static web page. I wanted to choose an example that, I found interesting. So we know that things like the NSA and encryption and spying are in the news, and of course retro is a fashion these days, so I thought I'd put the two together and come up with this. I created this page which talks about the Enigma machine, which some of you may know was an encryption device used extensively by the Germans in the Second World War and famously broken by British cryptographers. It's quite an ingenious device. I won't read you the whole page here, but the basics of its operation, the sort of thing that makes it go, are these rotors, which are disks that have random cross wirings in them. They were based on phone switches, and you can stack them together, and as you switch them around, they can make different combinations of random wirings. So you make a stack of them, and then you put what they call a reflector wire rotor on the end, which routes one from to the other. And when you put it all together, you make this complete circuit, like we see in this diagram. And if you were to press, say, the B key, you would create a circuit that would light up a light, the D light, and an operator would write down what happens. And as you press keys, these rotors flip, creating a new random combination each time. So you get something that is difficult, although it turns out not impossible, to break. If we look at this example, this is a five rotor machine, and you see the keys here, and that's where the light up would go. Well, I won't go into too much detail, but I put some time into making this page, and I want to share it with people. So to just show this static notebook, we can use our big red deploy button, which shows us all the different ways that we can deploy things. I'm just going to click Published Page here. And you notice I've got static web page selected. And if I just press the button, it gives me this URL. And if I preview it, now this web page is online. And here we can see all the content. And you're looking at basically the same notebook that I was just working on, only now in the view that anyone can see. In fact, if you're a really fast typist, you can type in that URL for yourself and look at it right now. Too slow. Okay. So that's the most basic kind of deployment that we can do, but obviously we can do much, much more. So what I'd like to do now is add some interactivity. So in this notebook, I've written some Wolfram language code to simulate that rotor stack. So if I evaluate this functions, you can see this is very, it's Wolfram language, it's very short. But these functions together I can use that and I can create a manipulate object. And what you see here is an interactive simulation of how this works. So with the A key pressed on the first setting of the rotors, I'd light up B, and as I slide this little slider, I can move this a few times, and you see how each time this represents a shifting in one of the rotors, I'm creating a different random result. So here we see I press A, here's the circuit, and D would light up. And now you notice, if I select D, A will light up. The trick to how this whole works is the circuit is symmetric, so if the receiver has his rotors set correctly, when he types the message back, the encrypted message back in, he gets the plain text back out. So this interactive diagram is a real nice way to see how this works. So I'd like to share it. So the first thing that I'll do is, I have to go back and open this notebook here. Let's go back to this notebook. And let me just go ahead and place this. Now let's see, I must not have copied it. Okay. Let me just get all of my should just be able to copy and paste. There we go. And now this is part of the notebook, and we slide it. We see it's interactive. Now, right now, I've shared this as a static notebook, so this interactive element isn't enabled. So if I go back to my deploy menu, you'll notice I have a second choice, which is Cloud CDF. Cloud CDF will enable interactive elements that require calculation resources in the cloud. So you'll note that in this case, if people use this, they'll use your Wolfram Cloud credits. But I want people to be able to have that interactivity, so I'm willing to do that. So I've generated this URL. Now I preview this here, interactively embedded in here. And if you type that URL fast enough, you should be able to try this out at home. So now I've been able to share both static and dynamic content. I have some other options as terms of how I want to share this. Another choice, if I want to put this in my own notebook, but say I have a different web page where I'd like to include this, we have the ability to share a cell. This would share it as its own notebook. I want to embed this. So this is going to give me some code. I want to be Cloud CF. Make this a little bit taller. I don't know how big this is. We'll find out. So I generate this. This creates a new cloud object, and it gives me the HTML code to embed it. Make sure I copied that. And just to show this working, although this is a bit and this is how it might embed in your own web page. So this is what you would see if you embedded this object in your own web page. Of course, you can twiddle with the parameters here to get it to fit the way you want. So that's an alternative way to share some of this dynamic content. Okay, moving on. Let's see here now. I want to go back here. So I've done some static content and some interactive content. Now I want to go to full-on web applications. So in this notebook, I've created a full-on simulation of an Enigma machine. Now this code handles the simulation of the routers, the rotors. And it turns out there's another aspect of this that's not that important for this talk. There's actually like a phone plug board where where you put plugs in and you can actually reroute certain letters. So I've just thrown that in for good measure to make it accurate, but I evaluate this. And this code altogether defines this Enigma encode function. And to show you how it works, here's a setting for the rotors. They go through the letters of the alphabet. And here's my secret message. I evaluate it, and I get this encrypted text. Now, if I start with the same settings in the encrypted text, you see I get back my secret message. Okay, well that's interesting for me, but now I want to be able to share this with other people. Okay, there we go. So I want to create an application on the web that allows anyone to make their own secret messages. So I use the form object, which I think Chris showed in his talk. This is fairly complicated, but it's setting up settings for each of the rotors and an area for the secret message. So this is the form object. This is sort of the contents of the form. I put that into a form function. What the form function does is it's going to read off the content of that form, and it's going to provide that as arguments to this Enigma coded function, and it's going to return it as text. And then I'm going to cloud deploy it. Now I want to emphasize something that surprises me the first time that I learned about this. When you deploy a form function like this, you notice I just include this Enigma encode function. But when we looked up there was all sorts of other code that it was dependent upon. When you cloud deploy, you don't have to worry about that. We figure out all of the dependencies that the function has, and we make sure that the cloud object is set up with everything you need. So all you do is deploy something very simple like this. Behind the scenes, the magic happens, and you get a form that includes all the code necessary to generate a secret message. And so if we try this out, be sure to drink your Ovaltine. All right, our canonical secret message. And there it is. And if we go back and set this up again, that should work. Be sure to drink your Ovaltine. So we get our message back. So that is one example of a very powerful deployment option. If you can create a sort of form-driven input thing, doesn't matter how complex it is, create a form for it, you cloud deploy it. In this case, I set the permissions to public so that everybody can see it, and then people can go on the web, enter data into their forms. Didn't need to click that again. And now they can generate secret messages on their own. Now, as an alternative, if you want to use this in some sort of other application, maybe you're making a secret World War II game and you want to generate secret-looking German messages and you want to be extra authentic, you can deploy this as an API function. So I'm just going to, we have two choices here with APIs. We can use the Wolfram language, or we can use the Instant API wizard. So this is our Instant API wizard. And if I choose this function, you notice that it sort of sets up, the wizard sort of set things up for me to deploy. Now it turns out my function, the inputs are a little bit complicated, and they go just a little bit beyond what this particular wizard is really strong at. This is a great place to start if you haven't done any deployments before and you're not too familiar with the Wolfram language. In my case, I want to do something a little bit more sophisticated than that. So I'm going to go ahead and go back to the Wolfram language. And you notice I'm going to use this API function. It's using code very similar to the form object, setting up each of the arguments these restricted sort of guarantee that I get correct inputs. And again, here's my Enigma encode, and I ask for text out. And the way API functions work is you can apply them to these associations. So this is what gets passed in. And here's our secret message encoded again. I think we're all beginning to recognize the secret message. And so I'm going to cloud deploy that. And again, I'm going to set it to public. If I were to click this, we'll notice it doesn't actually work because I didn't give it any arguments. But we can use this handy dandy we can resend it. Notice now the URL has all of the correct settings, and here's our secret message back. And just to prove that it all still works, there you go. So that's an example of how you can do APIs. Here is just the same thing. Within a notebook, you can access it using our URL execute. You can use embed code with multiple languages, as Chris was discussing in his question and answer, to embed this in many different kinds of apps using different languages. All right. One final thing, because we're running short on time. One last major kind of deployment is what we call our instant web computation. So again, I've defined this function. I have one last problem. If I want to send secret messages to my friends, they have to know what secret keys, the three-letter combination to use. We all have to agree on what to do. Well, I could, call them up and tell them, or send them an email or something, but that's no fun. I want a secret way for them to know. So I've defined this function, and what it does is, it turns out we have the full text of Hamlet. So I've loaded the full text of Hamlet and stripped it of everything but letter characters, and then I took the day since the beginning of this year and multiplied by 3, and that's the offset I start in the text, and then I read 3 characters. And that gives me 3 randomish characters to plug in for my secret key. And every day I can go to the web page and I can know what secret key to use. So I have this function. And so today is SAI. There are 2 ways I can deploy this. The first way, again, with our instant web computation. And again, we can go directly to the documentation and use the Wolfram language, or we can use this. And so here is this one. And I would click publish, except for one problem. If I click publish, then anyone who knows this URL can go there and get the secret keys, and then they can read our messages. And that includes people we don't like. So instead, I'm again going to use the Wolfram language and cloud deploy. And the secret here is this delayed function. What this says is, don't evaluate this now. Evaluate it when the page is loaded. And here's my function I'm saying today. So I can always, whenever this page is loaded, I can get the value for today. And I set the permissions so that myself and some of the people here are on the sort of list. Fortunately, you all out there, not on the list. Sorry, can't get by the velvet rope. And if I click this, then you see I get today's secret combination. If I come back tomorrow, I can get another one. So pretty much what we see now in various combinations are all of the deployments. I haven't covered every single one of these menu options, but we did an instant API. We did a web computation and a form. Form-based mobile app is a variation on forms, includes some, including icons in order for it to work within our app, or later on we'll be able to embed this in Android and other apps. We published a page. We did do embeddable content, only I did it through the cell gear menu for a particular cell. So that is a quick tour of all the different major types of deployments, and should give you a pretty good idea of the capabilities of our system.
The URLs that are generated, or these strings of numbers and
Right.
characters, can those be renamed?
In some cases, let me see here. The most cloud objects are accessible. Cloud objects are accessible as these UUIDs, but they're also accessible using your base name and then the name of the object. Now, when I just cloud deploy, I'm creating objects with UUID names. You can, here, I'll just also create them. I think this is the, well, we'll find out real quick whether this is the syntax or not. The API function, this would be C. I apologize for not knowing the exact syntax. I'll have to go look that up. Maybe at the end I'll figure that out. Next question.
Sure. Where is data saved, and how long does it persist? Is actually
So
one.
forms data. You mean the things that you enter into the forms?
This is
or
the question.
Actual form. Okay. So the actual form itself is a cloud object. It's stored in your online directory, and for anyone who has a paying account, that form will stay there until you delete it. For the free tier, we do have the option to delete deployments after 30 days. Someone's holding up their 3, so it's 30 days. So whatever's input into the form is just fed into the analysis, and then it's done. So yeah, that's the way persistence of forms happens. I mean, your form itself, if you want to save any inputs to it, you can use put and save it into your cloud file system. So if you want to create a form that's just collecting data, it can do that. And you can store as much data as your storage limit allows.
Okay. And they can create packages in the cloud, I suppose?
Yes, they can.
Yeah.
You can create .m files, new package. You can do that. You can create a .m file, store it wherever you want, load it up using get like you would load any other package.
And what does the end user need to have in order to access these things? Do they need to download any special packages, or?
If you want the end user to be able to download your package, for any cloud file, you merely have to set, if you want people to be able to read it, you just need to give public read permission and then the URL, and then they can just fetch it. They can just
in the browser.
In the browser, they can get it, or they can, or they can use a utility to read it.
I'm going to. There are several questions about formats and such, and accessibility and so on. Will there be an Android or iOS app to access the programming cloud?
We are yes and yes. I have seen versions of the iOS app. In fact, Stephen Wolfram demonstrated the iOS app rather amusingly in his talk last night. He put it on his desk and aimed a camera at it. That is in development. I don't think it's released yet. I know we're working on an Android app. I don't know what the state of that development is. It's probably a little further out.
So in terms of formats, I can sort of summarize this. We've got a question about JSON, XML, SOAP. Do you want to cover, anybody want to talk about the formats in which things can be exported?
Let's see here. If we just do like instant web computation, and let's look at the wizard, it probably lists many, if not all, the formats. So here are some, if not all, of the formats. And we have text, image formats, HTML, JSON, XML, PDF.
So
CSV.
they can read this on the...
Yeah. So that's, I'm not going to, I think that essentially we have the function export form. Are people seeing my screen, or are they seeing me? Okay, they said you're seeing my screen. That's excellent, because that's better than watching me. Export form, I think essentially any of these types that are documented in export form are supportable in the cloud.
Okay. And what about languages? So you have Java compatibility, and but when can we expect support for Haskell? Can you compile to C? What about access to MySQL database content and so on?
So in terms of embed code, meaning giving you code snippets to call API functions from whatever your favorite language is. It's a growing list. I don't know where Haskell fits on that list. I don't know if we have an experienced Haskell programmer in-house. If you look at examples, I mean, essentially, the code snippets are effectively doing HTML calls. So if you're a Haskell programmer who already knows how to do an HTML get in Haskell, you're pretty much already there. I'm sure we'll be adding more languages if people ask for them. We'll find someone who knows how to write it and put it in there. What was the other question?
Things like database.
Database connectivity. The database access kit is accessible in the cloud. I don't know if it's accessible at all tiers or if it's limited. Every tier? No, it's not every tier. So you may have to pay. You may have to be a paying customer to be able to use that. But it works in the cloud. You have two choices. You can use a local database, where a file-back database, and then you can just use your own cloud storage. Or if you have a MySQL database, you can access that. The only issue is it's going to have to be reachable from our cloud. So that means it's going to have to be on the internet, and you'll have to work out the credentials to make sure that you can use it and people you do not. And Clayton's holding up the word producer. At the producer level, you can have database access kits. So it is available for premium members.
Okay, thanks, Andrew. I'm going to move on to the next presentation. As you know, there's plenty of time for more questions as we go forward. So now Joel is up. He was going to be talking about cloud objects and what those are, and you want to take it from there? Sorry.
Absolutely. So Andrew went over how to deploy things from your browser, and we're going to be looking at a little more at getting more in depth into some of the questions that Andrew was actually answering. But also we're going to be using, in my presentation, the Wolfram desktop. So this is the native application that lets you deploy, manage your cloud objects exactly the same way, the same set of files, but in a native application. So in this case, I'm using my laptop. So what are cloud objects? They're really just files stored in our cloud. But there's a few wrinkles that would be good to cover. You can access them either from your desktop environment or the browser. How do you create them? So here I've done a cloud put. If you're familiar with Wolfram language, you're familiar with put. And this is the same concept, except the file goes in the cloud. And I've got an object here. It's got a cloud object head, and it's got a link inside. I can click that link. It'll take me into the cloud, and after I sign in, it'll actually take me there. So that's me viewing my cloud object that I created in the desktop, but viewing it through my browser. So let's break down what just happened when I did that cloud put. It created a new cloud object. I didn't have to specify a file name, if you noticed. It made one up. It assigned a universally unique identifier to that object, and it also gave it a MIME type. MIME type is a type that indicates how the cloud object should behave. In this case, it was an expression because put always creates expressions. And this cloud object also has options that modify its behavior. So it has permissions and icons and meta information, key value pairs. There's a bunch of things that just happened when we created this cloud object. There are some other ways to create cloud objects. I can go from code and create an animated GIF. This is a GIF I created using the GIF exporter from Wolfram language. I can deploy a web page, a static web page. I can create, and notice these have different MIME types. So the GIF obviously is a GIF file. The HTML page has a type HTML. I can copy a file from my laptop into the cloud using copy file. I give it a local file path. Let's check what that is. So it's a file here. and I copied it, and I specified cloud object of, and I gave it a name. And I'm going to click the link and find an old Rembrandt in the cloud somehow. So there's a variety of ways to actually get files, get cloud objects there. I can also retrieve them. I can reverse the arguments to copy file and say, well, I'm copying from the cloud to my local desktop. So this is a very powerful mechanism. You can move files in and out scriptably like this. It's a very simple model to understand. And I want to say just a word. Andrew answered this. Somebody asked a question, can you rename it? So here are the things to remember. All the cloud objects have a UUID. Some cloud objects have a name. I gave a name to a cloud object. The ones that do have a name, I can rename. And the ones that don't are unnamed. And I wanted to show you in the browser where you can find those. In the file sidebar, there's going to be an all files and an unnamed cloud objects. This lets me browse the ones that have never been given a name. And I can find, using these icons, I can find ones that I created just now. But we can also list them here. The cloud objects function allows you to enumerate these. So if I say none, that tells me cloud objects that don't have a name. I can ask to do a directory listing, so cloud objects in the current cloud directory. I can also ask for cloud objects of a certain type. So cloud objects of type goes to API function. This is giving me all my APIs, whether they're public or not. I can ask for forms, I can ask for instant web computations, I can ask for plain old expressions, notebooks, a variety of others. So if you dig into this, you'll find ways to track these down. I can also manage these. Picking a random cloud object, I can ask all kinds of questions about it. Does it exist? Is it a directory? What type is it? How big is it? The super utility function is cloud object information that gives you the lowdown on everything, including permissions and the MIME type that I mentioned, creation dates, last modified dates, and all those things. So you've got a pretty comfortable, these are all familiar operations that you can do on files. You're moving them in and out of the cloud. So you can access all these things this way. And now I wanted to show you, using the desktop environment, how to do some deployments. So I've got a particular problem that I've chosen for this demonstration. We're going to talk about photographic flash for a second. I would like to be able to use my photographic flash to properly expose a subject, and I want to know what power setting do I use. Do I use it full power? Do I use it at the minimal power? And it turns out there's a calculation for this. Given a number that the manufacturer tells you, the guide number, and given the lowest power setting, that's out of a form 1 over 2 to the n, so it could be 1 over 32 or 1 over 128, we can compute the distance that the flash and the subject need to be apart from each other to have the photograph correctly exposed. And there are solutions out there. Nobody's not figured this out. You can do trial and error. You can take a picture and see, is it underexposed, overexposed, tweak the settings. That's kind of inelegant. You can buy a light meter and do this. You can buy an expensive flash that has an automated system for it. We would like to do this through a computation. We just like to know the numbers, set the power in one step, and not pay anything. So I have encoded this calculation in Wolfram language with this power function. We've got a list of common f-stops for the camera, and I've got a function that will give you a very handy table that somebody could print out and take into their photo lab and just set the power settings on their flash. So I've got these functions, and I test them a little bit. I create and manipulate that lets me interact with it and pretty quickly get an idea. Does it seem to be sensible? I've got an example of one of these tables. It looks good to me, and I want to get it out there. And I've got a couple of choices. I can do an API endpoint. I think in this case, I'm going to do a form. We want a form that's going to accept these numbers as inputs and give you the table. And I've specified it's going to be a PNG image. So I'm checking this out. I give a couple of common numbers, and there we have it. Anybody can use this form, get the table printed out. I just heard that somebody wants this in PDF. So, okay, let's do that. Instead of, I'm going to run the API version for a second. So at the very end here, the end user can specify a different export form. You can override this, but the end user can say, I would like that in a PDF, please. And there I go. I didn't have to change my code. I could just tell somebody to add that parameter, and now they've got it in a format that's more suitable for them. I am very excited about this, and I'm going to tweet, it works. Try the new lighting form. And let's see, did I call it form? I did. And I have just tweeted my deployment. And now, of course, what you do, anytime you publish something, you sit back and wait for the page hits to come in. And my last step here is going to be cloud logging data, where I can get all kinds of information about who is accessing my form, how often, some graphs, and there's too much to digest here. I see that my time series shows it's going down, so maybe I go on my social media again and pump it up. But this gives you an end-to-end code to tracking my deployment in kind of one step. So.
Good. So do you, are you willing to field some questions about how they can deploy it on their own server, like on an internal server or something like that, the Wolfram Cloud objects?
So if you have the private cloud, you would set that up on your own infrastructure, or possibly host it in Amazon Cloud and managed by us, and you would be able to go through the exact same steps. You would be connecting through a different cloud base in that case. Cloud base is just the base URL. In the default, it's wolframcloud.com. But you'd go through the same steps and deploy it on, in your copy, essentially, of the Wolfram Cloud.
Okay, that's the private cloud.
That's private cloud option.
And that exists. I mean, that's publicly available now, or is that a future release?
It is coming soon. It's not completely available right now, but it's definitely an option that I would be asking about. Yeah.
Okay. Yeah. And others have asked. But about what about data security? Do you want to say anything about that in terms of on the public web?
So there's a couple of options if you're interested in securing what data flows when people are requesting your deployments. I believe all of the URLs we're using to publish are HTTPS to begin with, and so the interactions are going to be secured. You can actually restrict your deployments to people that are authenticated who also have Wolfram IDs, and so you have a little bit of control over who can access your deployments that way. If you want to choose one or the other.
So this is something between private and public?
No, in the private and public permissions, you mean. You can make a public deployment, right, and anybody could access that, whether they have a Wolfram ID or not, whether they're logged in or not. you can set permissions to grant particular users access to your deployment.
If I actually, let me go to this one. Is it possible to make a commercial app? In other words, make an app that people can only access if they are I mean, where you can charge a fee to the user?
Absolutely, and that's part of the intent, is that this is a platform for people to develop on and sell to others. So you could use similar mechanism as we were just talking about to authorize, this is an authorized user of my deployment, or I'm going to give a message that says, here's how to subscribe to my service.
So if I'm a startup, just a web startup, and I want to take advantage of this new technology, there is a way to be the cutting edge, so to speak.
Absolutely.
Yeah. Okay. If I deploy a manipulate object in the browser, do file open, read, and write actually work in that object?
Yes.
Okay.
You can do pretty much anything in a manipulate that you can do from APIs.
Okay. So I have to say goodbye to Joel for just a moment. He's going to be replaced by Clayton Voyles for the last presentation. And while they're doing that, I was hoping that Chris could take a couple of questions. Let me just scroll over to them. Where are they? The Facebook API, that's right. Is it possible to access other APIs such as Facebook data, and are there any interfaces available?
Yeah, sure. Let me give an example of that. Hang on just a second. Let me go to Wolfram Desktop. So there's something called Service Connect, which connects to all sorts of different services like Facebook. Let me just pull up the documentation for that. So it's Service Connect. You give it the name of the service, and those are listed here also in the documentation. You can connect to Twitter, LinkedIn, Facebook, Google+, Instagram, lots of them, and I'm sure that list will be growing as well. And I think if you go to www.wolfram.com/language/gallery, there are examples there. I know there's an example of accessing your Facebook Friends network and analyzing that. And I believe there are also examples of using Twitter. You can send tweets, all sorts of things.
Yeah, Joel showed us that as well with tweeting his own URLs. Yeah?
Sorry, I did.
Did you want to add something?
I just wanted to add that currently from the cloud, this is not available, but it should be shortly. There was one or two features we didn't get in for the beta that were necessary to enable us to work, but it's tops on the list.
Okay.
So it may be a few weeks or a month, but we definitely want to be able to give people access to Service Connect on the cloud.
Yeah, and you don't want to underestimate the complexity of what's happening here. How many people are involved in making this thing a reality?
Yes, I need not underestimate the complexity.
No, you need not, but I mean our readers. I'm sure you're aware, our listeners. And I'm going to switch actually to Clayton. Introduce Clayton Voyles. He's a lead business analyst here at Wolfram, and he's going to talk about accessibility and like subscription issues and pricing and so on.
Thanks a lot, Philip. We're very excited to talk to you about all the different offerings. From looking over social media this morning, it seems like many people are excited about it. And we want to put the language and make it accessible to everyone. And as a result, there's a variety of plans, including a free one. So what I'm going to do now is I'm going to go ahead and give a quick tour of what are the different options, what do they provide you, explain cloud credits, because I've seen quite a few questions come through about that, and also explain how can you get the Wolfram Desktop option as part of one of your plans. So first I'm going to go ahead and start from the marketing page for Wolfram Programming Cloud. So if you're here, you scroll down and click on Sign up for Cloud Access. This will show you our pricing page. So I'm not going to sit here and read everything through to you. You can check this out later, but I want to kind of just make sure everyone understands what are these plans, who are they for, and what are some of the features. So first of all, as you can see, there is a free plan. And again, as I saw on social media, people are really excited. Anyone can hop in with Wolfram ID, and you immediately can be in a notebook, start playing, learn our language. And as been mentioned before, there's many examples to kind of challenge you and show you neat ways that you can kind of accomplish things with the Wolfram language. To be transparent, so the free product does have a couple limits. For example, we limit the amount of storage that you have, and also any deployments that you make will expire after 30 days. Again, this is enough for you to test, learn, play, and show to others. The next tier is the Explorer one. Here, the big difference is your deployments persist, plus you have more resources. So this allows you to, let's say you had a great idea, you figured it out, and you want to share it with others. Whatever you make will persist as long as you have an account with us. You can show it to whoever you want, and maybe even get some friends to join you and collaborate on an idea. The developer tier is the next one. I just want to pause real quick and point out that, as you can see the prices, if you do annual, there are certain benefits. It's cheaper. And also right now, there's an introductory offer. If you sign up for the WPC developer plan, you can get the Wolfram desktop with an annual subscription. What is the Wolfram desktop? That question's come up a few times. It came in chat and also in conversation. The Wolfram desktop, if you have access to it, which you get with an annual subscription of developer or with any Programming Cloud producer subscription, that gives you actually something you can download. You can use multiple cores on your desktop, and you can actually use cloud files that you created in the web browser or through Wolfram Desktop. So it's very powerful. We've already heard some good feedback this morning from people that have it, and they like being able to switch. They aren't tied to one machine. They can do it on the go, or they can do it on a very powerful computer in their office. All right, continuing our tour. So developer, as you can see, you kind of scroll down, there's a lot more resources here. I'm starting to get the ability like customize URLs for your deployments. And on to the next one, producer. Producer is what we think, and also what people are saying so far, is kind of our most professional offering. You get some advanced development features. You do get the Wolfram desktop. You get a whole lot of resources for cloud credits, Wolfram Alpha API calls, 25 gigabytes of storage, and soon you'll have the ability to add additional seats. So let's say it's time to collaborate. You have a couple people that want to work with you on an idea or an application. You can go ahead and purchase an additional seat, and they can work with you. You can collaborate and come up with some results. The team tier, we do have that listed right now. This is not available to purchase yet. We're working on this along with the private cloud. When those come out, we will, of course, notify everyone and change this page. So a couple of questions still I want to go over before we end this section is, what are cloud credits? That is a great question, and to be honest, it is a little bit complicated. This is something new that we've come up with, but we think it makes it very accessible, and it also gives you a lot of flexibility in how you want to use your resources. So the best way to explain cloud credits is, just so you know, from this page you can go down, you can read a little bit about cloud credits, and we actually have a page specific to cloud credits. Each plan comes with a number of cloud credits, and you use them for deployments. They power also access to specialized knowledge from the Wolfram knowledge base. Also, if you want to use some, let's say, semantic functions and utilize our natural language functions, that will use cloud credits. We do not charge cloud credits if you are in the notebook and just doing calculations. And I want to make sure that's very clear. A lot of questions have come where people think that just to be in the notebook, doing 2 + 2, we're charging you cloud credits. We are not doing that. Cloud credits only they only impact you in the notebook if you are, again, let's say you're doing, you're requesting some specialized data about aircraft, and you're actually making a call to the Wolfram knowledge base. That would cost you cloud credits. But generally, cloud credits are used for deployments. So let's say you have an instant form that's been deployed and people are using that. How they use it and the code that you've used, that dictates how many cloud credits are consumed. So again, that's just kind of a high level. There's a page here that explains cloud credits in more detail. And if you have specific questions, you can send that through the Q&A. One last topic here is other products. I know we've been talking about Programming Cloud, but this is just the first of many exciting products that we're coming out with later this year. And if you are interested in what they are, you can go to wolframcloud.com. From here, you can click on them. And also, there's some exciting new ones we haven't even announced yet. You'll see these tiles start to be filled in. So we look forward to hearing how you use our product. And please let us know if you have any feedback, submit it through the product. We're really excited to continue to evolve this product.
Yeah, so take some specific questions for Clayton.
Okay.
There are a couple. Yeah, if I want to write an app for commercial purposes, at what level would you recommend that I subscribe?
It's a great question. It's hard to really say that someone minimum needs one tier or another. One of the great things about including cloud credits for free in every single plan is that we're giving you enough to where you can make a deployment, you can test it out and go to the dashboard and actually see how many credits did that cost me. So with that capability, you could start at a tier that you're comfortable with, see how many credits you might use per visit, and then scale up as needed. I will point out, obviously, that you get a lot more credits depending on which tier you have. And we have noticed we have quite a few subscriptions coming in for developer and producer because of that. I guess actually kind of tie on to the end of that question. Additional cloud credits, they can be purchased. This is limited to certain tiers. So if you have the developer, producer, or team subscription, that gives you the ability to purchase more cloud credits. So let's say you don't feel like you have enough in your subscription. We do give you the capability to purchase more. As you can see here, at the most expensive is 30 cents CPM. So 30 cents for 1,000 cloud credits, very cheap compared to the marketplace.
Okay, thank you, Clayton. Joel is actually going to rejoin us, and while that happens, I'm going to ask a few more questions to the rest of our panel. There was a question that, about compatibility with Ruby and Perl. That's a question that you were interested in addressing, Chris?
Sure. I mean, so there have been lots of questions come in about compatibility with various languages of all sorts. And so typically the way that you call something that's been deployed in the cloud from any language is you use embed code to give you the code that you drop into your project. And that's really just boilerplate code with the URL for that cloud object embedded in it. So if you know, in whatever language you're interested in, if you know already how to do an HTTP GET, then you can just call that cloud object. So essentially, it's accessible already from all of these languages. You just have to know how to do that HTTP GET.
There's a subtly similar question to something we had before, which is, what is the difference between the Wolfram Cloud and Mathematica Online?
Mathematica Online is the online product that will be associated with Mathematica. So presumably it'll be something that you can purchase when you purchase Mathematica, or if you have a site license, that it can become an option. It will be similar to WPC. You'll be able to do all the same kinds of deployments and use the Wolfram language. The user interface will probably be somewhat different. Some features won't be emphasized in the same way. Mathematica Online won't emphasize strongly the way WPC does creating and deploying. So its emphasis will be more using notebooks in the cloud for when you're away from your computer, or you don't want to use a heavyweight app. But fundamentally, they're both driven by the Wolfram language. They'll use the same kernel and have the same capabilities in the Wolfram language. And then the only differences might be features and storage and whatnot that you get depending on your plans.
Mm-hmm. Wolfram Alpha comes as XML data,
right,
and formatted in a certain way. Is it possible to access the raw number data from Wolfram Alpha?
What you can do, so in the cloud, in an interactive session, you can use equal and double equal, just the way you do on the desktop, to get Wolfram Alpha data. You can use the Wolfram Alpha function that's defined in the kernel to get data from Wolfram Alpha, and all the formats that it permits. I don't know what all of those are. There is one limitation to using Wolfram Alpha data in the cloud, is that the full Wolfram Alpha function is restricted to interactive notebook sessions. Unfortunately, we can't, at this time, allow people to use deployments to deploy things that call the full Wolfram Alpha. It has to do with data sharing and licensing agreements we have with partners. It's, as you might imagine, a complex topic involving lawyers and fees and whatnot, and it's a difficult knot to untie. And so at this time, if you want to create something, if you create a deployment that includes the Wolfram Alpha function call, it will unfortunately not work for you. But within the interactive session, you can do everything on the cloud that you could with the notebook interface that you do on the desktop.
More cloud-related questions then. Here's one viewer is writing, I've tried the free cloud version today, but it appeared that I couldn't interact in the normal way with objects before deploying them. For example, if I use Plot3D, I cannot rotate the figure by dragging it. Is that expected? So I guess it's somebody who's familiar with the Mathematica version of this, but isn't. But maybe something needs to be done differently in order to work on it in the cloud.
Graphics rotation does work for many browsers in the web. Without knowing which particular one, I'm not signed in. For instance, on Mac with a Chrome browser and also with Safari, click and drag rotation of 3D graphics does work. Resizing of 2D graphics works. So those interactivities are built in. It's possible that your operating system and browser combination doesn't support WebGL. It may not support WebGL, and that may be why you're not seeing the 3D interactivity. So I think so I think if you're having issues with that, I guess if you can send in a support question if you get support, or go to the forums, and people can let you know which ones do work and which ones don't have the horsepower to handle it.
There are some questions about advanced programming. I don't know who wants to take these, but is things like parallelizing and multi-core processing and GPU capabilities, are those possible on the cloud, or in the cloud rather?
I'll take a stab at that. So there are different answers because those are different technologies. Parallel is going to be coming with an HPC option that we're developing. Right now, the parallel functions that you may be familiar with, the parallel map and parallelize and things like those will issue a message, but they'll work because they fall back to a compatible serial equivalent function. Things like the OpenCL and things that are using the graphics card are not supported right now because those take some specialized hardware. They take a special virtualized environment that we're not doing presently. Those are very exciting ideas, and we definitely have thought about them and definitely see them coming at some point, but they're not available right now. Multi-core, you're going to get multi-core speed-ups implicitly for certain functions that you would ordinarily do on the desktop.
Well, the questions are still flowing in, quite a lot of them in fact, but we are out of time for the live version of the live portion of the presentation portion of this event.